just like the basics of the rest of this course. So, we said also, on your table 4, gives you a little diagram. The curve is shaded to the left. So whenever you look this area up, it's area to the left. So when I look up this z-score, and I say, what is the probability that z is less than negative 1.33? I want the area to the left. I look up negative 1.33. Now be careful when you look it up because it goes the opposite direction. And I get 0.0918. Get this? I have the wrong one? Yes. I need you to make sure you know how to do this. Okay. If you have any questions, stop me. The area to the right is a little bit different. The probability, and put your z-score probability down here, that your z-score is greater than this. How did I know I need to say greater than? How did I know to set my probability up with a greater than statement? It wants the area to the right. So I'm kind of pointing my arrow to the right. How much area sits to the right of this z-score? Now, when I look this up, this is a really large number when I look it up. And I say, could that possibly be 99% of my curve sitting in that little spot? No. Where is my 99%? On the left. So therefore, you have to say 1 minus this. Makes sense out of your curve. Isn't that a lot smaller? 0.0096 is less than 1% of your curve.
Do we have to put the inequality?
I wanted you to get used to writing the probability statement because I want to pull in your probabilities with your areas.
Okay.
Which is why we learned a lot about probabilities, and the sum of all probabilities is 1. The area under your curve is 1. So hopefully you will start to pull all this together. You didn't have to, but I was hoping you would try. Now, what's another way to do this? Using the symmetry of this curve. What's another way I can look this up? Good. I can go to the negative 2.34. And shouldn't this area be the same exact as this area? Good. This is my positive 2.34. They're the same distance away from 0. 0 is your line of symmetry. So the area to the left of that curve is 50%. The area to the right of that curve is 50%. I could take that curve and I could fold it on that line of symmetry. So this little piece out here, when I look this up, when I look up negative 0.234, is 0.0096. I can look up the negative side of it and not have to subtract it from 1. Make sense? Now, I thought you guys were quiet yesterday. 2 days in a row can't be possible. Okay. Probability with an in-between. That means I want my z-score to be in between these two guys. In between, the negative has to go over here, just like you read a number line, and the positive. And yeah, I'm symmetric. I'm both the same distance away from the curve. But when we find in between, we take the areas and we subtract the areas. We take the larger area, which would be this area, and we subtract the area of the smaller one. Because areas can never be negative, right? So we're always subtracting the larger minus the smaller. So we look up a z-score of 1.23, and we get 0.8907. We look up a z-score of negative 1.23, we get 1093. and we subtract these guys. And let's see if this makes sense. On all the things we know. We know that the plus or minus 1 is 68%, right? We know that the plus or minus 2 is 95%. So we're somewhere between 68 and 95. Is 78 somewhere between 68 and 95? Puts us in the ballpark, right? Did you understand the way Khan Academy guy did it yesterday? Like I do mine a little bit differently. I based it off of 50%, but he did it based as a symmetrical curve. So are we okay with these so far? Everybody could do this. So if I gave you a quiz tomorrow, you could do all this. If I gave you a quiz now, oh, now I'm going from yeah to probably, and I got a no.
Yes for me.
I got a yes from Sarah.
Yes for me.
Yes here too. Good. Good yeses here. Okay. Sketch the curve. So I want to start like this. All curves start like this. Even his curve. Did you see how exaggerated his curve was too? His curve was exaggerated. And the reason we exaggerate that, if we made it too close to the edges, you'd never be able to fit your 2 and your 3 in there. So we start like this. Okay? Where do I find, I should have labeled these. Where do I find 1.54? Between which two integers do I find 1.54? 1 and 2. Almost in the half, right? Now, we're gonna keep our z-scores on the bottom. When we do x values pretty soon, we're gonna keep those on the top. The book does it a little different. I don't like the way they do it. I like the z-scores on the bottom, the x values on the top. I want to the left, so I'm gonna shade all this. Should my answer be greater than 50% or less than 50%? Greater. Isn't it more than 50% of my curve? It's a good chunk more. And I know this we remembered saying 68 divided by 2 is 34. So 50 plus 34, it has to be greater than 84%, doesn't it? Get a ballpark. Get a ballpark so that you get a feeling for this. So I got the probability that the z is to the left, less than. I look up my z-score, and I get 0.9382. All I want you to do is give me 4 decimals. Don't move the decimal place. I don't need the percentages. I just need the area. All the areas add up to 1. So I need you to give me the areas under the curve. Good? Okay. Again, start off with your curve. Everybody's going to start with the basic curve. My probability. What's my probability statement? Z is what? What is it? Well, how do I say it? Greater than, less than, equal to. I want to the right. Greater than. When you go to the right of something, it's greater. When you go to the left of something, it's less. Think of your number line. All the numbers to the left of a number are less than that. All the numbers to the right of it are greater than that. So, between which two integers do I find negative 0.95? 0 and negative 1. Probably real close to the negative 1, right? 0.95. I want to the right. Ballpark. Should my answer be greater than 50 or less than 50? According to my graph. Greater than 50. Aren't I more than half of this curve shaded in? When I look this guy up, negative 0.95, I'm only 0.1711. Could that be possible?
What?
For this area?
No.
No, so what do I have to do? Subtract it from 1. I don't want this little piece over here. It's giving me this little piece over here. I don't want that piece over there. I want to subtract it from 1. I want the greater piece. That's why your sketch helps you. If you look up a number and it's small, you expected it to be large, a little bell goes off. Oh, that's right, I have to subtract it from 1. If you didn't get any of these, let me know. These you have to know. Okay. To the left. I should see this sketch on every single one. To the left, how do I write the probability? Probability that z is what? Less than, negative 2.75. With two integers do I find negative 2.75? Negative 3, negative 2, a little closer to the negative 3, right? To the left. Well, is this going to be a large area or a small area? Small. Give me an estimate. How small? Just give me an estimate. Mm. 2%? Okay, so you're like 0.02? 0.002, then that's 0.2%. So 0 wants to go very small on this. Do we agree? Very small on this? Very unusual that it's going to sit out by 3, isn't it? Like the plus or minus 2 is going to share 5%, so that's 2.5. Plus or minus 3 is going to share 0.3%. So that's really, really small. So we look this up, and she's darn close. 0.0030. Good job on that. Okay, to the right. And if we subtract it from 1, that can't happen. To the right of this guy, $1.45, right between 1 and 2. I want to the right. Guesstimate on this cat. What would you guess? So is it less than 50 or more than 50? This shaded in part right here. Whoa. This part right here.
I'm lost.
Okay. And that's what I want to know. Half of your curve is 50%. 50 here, 50 here. That's why shading is important. My shaded area, this whole half is 50, this whole half is 50. My shaded area is this little piece. This is 50% of my curve. This is more than 50% of my curve, out that way, right? So even if I cut it in half and said this was 75% of my curve, wouldn't I expect this to be somewhere like 20%-ish? Maybe? So it's low. It's got to be small. So the problem is now, when I look up this number, I get a big number. I get more than 50%. I look this number up, I get this. Could this little area be 92% of my curve? So it tells me to do what? Subtract it from 1. I only want this little tiny piece out here. So I subtract it from 1, and I get 0.0735. So think of it in percent. 50%, half my curve. 7%, this little piece out here, is that possible 7%? Absolutely possible. Absolutely possible. We did this. We did 50% up to here. We knew that this piece was 68, so we knew this was another 34. So even if you guesstimated that was 84, you'd be somewhere around the 16%. Is 16% a good estimate for that little piece? Absolutely. Absolutely good estimate. How do I write my probability statement? Z is what? To the right, greater than. Okay, the last ones are probably the little tougher ones, the in-betweens. Oh, so they're way down here. Sorry about that. Okay, in between. So I am between negative 1.53. Here's my negative 1.53. and here's 1.75. I want this area in between. Let's estimate. 90. I like that estimate. So from negative 1 to positive 1 is how much?
Plus 60.
68. From negative 2 to positive 2 is how much? 95. Remember you said kind of guesstimate those numbers. 95. We should be somewhere between 68 and 95. Probably very much closer to the 95, right? Because I'm a little more than halfway, almost there at the 2. So it's probably going to be around 90%, like Chris said. Somewhere bigger than 84%. We agree? Somewhere around there. So now the in-betweens. Sorry, I'm going to have to bring this up here. I look both of these areas up. All I want to do is look them up. What do I do to the areas? Subtract them. I can't get a negative area. So I have to subtract the larger minus the smaller. Because what happens is, this bigger one covers all of this. This little one covers this. If I subtract that out, I'll be left with the guys in the middle. So when I subtract this out, I get 0.8969. And how close was Chris with 90%?
Pretty spot on.
Spot on. So probability, Z is in the middle. Negative 1.53 to positive 1.75. Okay, and the last one, we're between 0 here's a 0, and 1.75. Guesstimate.
34.
40. So how much between 0 and 1? How much did we decide between 0 and 1? 34 was half of 68. And about halfway through here. So we know it has to be bigger than 34, right? It has to be bigger than 34. So when my z-square is 0, what is my area? How much area to the left of this 0? 50%, right? 0.500. That's half my curve. When my z-square is 1.75, I look it up. I get 0.9599. And we subtract these guys. So we said it definitely had to be more than 34%. That's about 46% of my curve. Remember, we really exaggerate those ends. Those ends really are so close together between the negative 2 and the 3, negative 3 and the 2 and the 3. They're very, very close together on the curve because there's very, very small area there. But we exaggerate it because we need to fit our work on it. As did he with concatenating, right? He did the same thing. Are we comfortable with SAT scores is an exam used by colleges and universities to evaluate undergraduate applications. The test scores are normally distributed. That line, they will always tell you. So that we say, oh, normal curve. The mean for a recent year, we're going to put it over here, is 1498 with a standard deviation of 316. They have 4 test scores. An X value of 1920, an X value of 1240, an X value of 2200, and an X value of 1390. They want to know we need to find the z-scores and to determine if any of these are unusual. And we're also going to find the area under the curve to associate what is the probability that I will get that z-score. Because probabilities are areas under the curve. So we're going to take this a little bit further. Now, we're going to take the mean, we're going to put it up here. You're going to take that mean, and you're going to add 316 all the way across. 316 is your standard deviation. So to get to one standard deviation, this would be 1814. Just keep adding 316. And I want these on the top. Good so far? It's like a number line, so it's less than on the other side. So we're going to go back to 1498, and we're going to subtract 316. Just keep subtracting 316. This will tie everything in together, hopefully. So our scores are ranging from 550 to 2446, because it's a pretty good size of a chunk of a standard deviation. Now, if you remember back, your z-score formula is x minus the mean over the standard deviation. So now, to find the z-score, I use my x value, 1920, minus the mean over my standard deviation. I want to see where I expect this to be. So I'm going to look for the score, 1920. If you look at the top, look up here 1 second. This is 1814, this is 2130. Shouldn't 1920 come in here somewhere? So approximately, what should my z-score be? Approximately. Just give me a loose estimate here. 1.35, 1.5, I would just round it to 1.5. What is the probability, or the area to the left of this? It's close to 90, because this is about 84 right here, so close to 90. So I have a 90% chance that a student, if I picked one at random, would have this z-score, would have this score. So I put this in my calculator. And be careful when you put it in your calculator. If you use your fraction key, you're good. Otherwise, you need parentheses around the numerator. If you put it in with the divide, or you use the 83s. So this z-score is 1.34. Oh, 1.35. Rondé was really, really, really close. Now, look up the area for this guy. Look up the area for 1.34. What's the area under the curve? What does your chart say? 1.34. $90.99. All right, now, everybody look up here for a second. The layout is our curve here. Standard deviations, x values. We want to know, what is the z-score associated with this guy's x value? This is Chris's SAT score. How good is his SAT grade? About 90% better than everybody else's, right? He's 90% better than everybody else. He's in like a 90th percentile. The probability that he gets this score, area under the curve. This is his ranking. He's better than like 90% of this group. When a college is looking at SATs, and we're going to do this probably too, they usually have a cutoff. They say, I'll just take the top 10%. Don't tell me what the scores are. I don't really need to know the scores. I'm the administrator. Give me the top 10% to look at. Does Chris fall within the top 10% that they'll look at? Yes, because this is what he's looking at. Does he fall within the top 10%? Yeah. He's at the 91 percentile. He falls within the top 10%. I don't care what the numbers are. I don't care what you got on your test. Just tell me if they fall within the top 10%. So what we're doing is finding a z-score, kind of looking at his ranking here. Area to the curve is to the left. All the areas add up to 1, 100%. We can figure out the probability that this will happen. That we will pick Chris. He's in the top 10%. And we'll hook these together. I know you're all packing up, but let's do one more. 1240. Where does 1240 fall? Between what two numbers? -1 and 0. Look at here. 1240 falls right here. So I expect my z-score to be somewhere like maybe -1/2.
Where are you getting all those blue numbers from?
From the book.
Oh,
From the problem.
alright.
From the problem. So now, let's find your z-score associated with that. They stopped at the z-score, but I'm just bringing you to the area for a minute. So the x value, do I expect my z-score to be positive or negative? Negative. So aren't I subtracting the smaller number minus the larger number? Doesn't that happen in my formula? I subtract the smaller minus the larger. That will give me a negative. So sometimes if you forget which direction the formula goes in, figure out if it's supposed to be positive or negative. So now when I do this, my z-score comes out to be -0.82. What's the area approximately? Approximately to the left. Is it more than 50% or less than 50%? Less than 50%. This person's SAT score is ranked more than half of their group or less than half. Less than half of their group. I look up this guy. Hang in there with me. -0.82. What'd you get? 2061. He's only around the 21st percentile, maybe. So if I'm college, would I want to look at these SATs, really? I'd say you need to do better on the SATs, unless you have outstanding scores. So this is how they're used in real life situations, these scores. Tomorrow we're going to finish this and do another one or two, and then we're going to have a little quiz on Friday.